Welcome, this is your teacher David Garcia, and today we will be working with hyperbola properties, and the objective will be to get the standard form of the equation of the hyperbola that has these characteristics. In this case, we're given both the vertices. We have vertex 1, vertex 2, and we have two foci, focus 1 and focus 2. Now, the idea, if you remember, for every single problem, this is to determine first if you are dealing with a horizontal or a vertical hyperbola. Now, we can do this by analyzing the vertices. So if we take a look at them, we'll see that the vertical coordinate of both vertices remains unchanged. The change is occurring on the horizontal coordinates. And the only possible way that this is happening is that if the hyperbola is horizontal. So being horizontal, we know that the horizontal term will be positive and the vertical term will be negative. So our formula will look like this. Now that out of the way, we have to get our four numbers. We have to get H, we have to get K, we have to get A, and we have to get B. Now, with this information, the H and K are rather simple. The first one that comes or pops immediately onto the side is K, which will be 8. So let's write that one down. And then H. How do we get H? There are different ways. If we have these two vertices, we can calculate the middle point. All right, 9 plus 3, 12 divided by 2 is 6. But if you pay attention to the foci, you will see that there's a 6 in here. And based on the idea that the x-coordinate, or the horizontal coordinate, excuse me, of the foci will be the value of h plus c and h minus c, then it'll be very obvious that this number that is being repeated on both foci is actually our h. So either way, we have that our h is 6. And now it's a matter of getting A and B. Now, A will be the horizontal distance, in this case, from H all the way to 9 or from 3 to 6. Okay, that it'll be the horizontal distance from the center to either of the vertices. So the differential in this case will be 3. No problem there. And then we get to the B. Now, we have a problem here because we don't have any information on the covertices. Okay, we don't have any information regarding the vertical length of the conjugate axis or anything else. So how do we get this? We have to look now for the third piece of information, that will be our C. So in this case, our C will be the square root of 58. Now, if you remember, these three numbers, A, B, and C, are related by the Pythagorean theorem. So we know that C is actually the square root of A squared plus B squared. And as we are looking for B, it's just a matter of isolating it. So let's isolate B. B will be the square root, there we go, of C squared minus A squared. So now it's just a matter of substituting them. So B will be the square root, there we go. C squared will be 58 and a squared will be 9. Now you can put this in your calculator. All right, there won't be any problem. So the square root of 58 minus 9 will be 49. Therefore, the square root of 49 will be 7. There we go. So now we have all the 4 values to write our formula. So let's begin. This will be x minus h, which is 6 squared. And this will be divided by a squared, which is 9. And then minus y minus k, which is 8 squared, divided by 7 squared, which is 49. And this equals 1. That's it. That's how you get the standard form of the equation of a hyperbola from vertices and foci. Thank you very much, and I will see you in our next video.